Okay, Bridge students, here we have the second in our series of videos on the Pythagorean Theorem. In the last one, I showed you a visual of what the Pythagorean Theorem means in geometric terms. Here, the objective is a little bit more narrow. It's that you're going to be able to apply the Pythagorean Theorem to find the side length of a right triangle. And so what we're going to do here is, I'm going to write out your objective right here, objective. Students will, or students can, use, I even use the word apply the Pythagorean theorem to find the missing side length of a right triangle. Doesn't get more classic than this, students, in terms of middle school math. So here we go. What are we going to do at first? Well, we're going to use this algebraic abstraction here of the Pythagorean theorem. Remember, the Pythagorean theorem is a visual concept, but we're going to use this algebraic abstraction, a squared plus b squared equals c squared, remembering that this means the sum of the squares of the two legs of a right triangle equals the square of the hypotenuse, okay? And we're going to write it down. Always I want you to write down the formula, just like with any formula-driven problem, okay? So here we have, oops, a squared plus b squared equals c squared. And there's a couple keys to this, and one is to remember that the hypotenuse is always c. It doesn't matter which leg you say is a and which leg you say is b, but it does matter that the hypotenuse, that's again the line segment that's opposite the right angle there, or else the longest line segment, if that's obvious. That always has to be by itself on one side of the equation. And from here, you just use your good equation syntax, you use your good equation solving techniques, and plug in the numbers. So side length c in this case is going to be 13. So we say that this is 13 squared. B is what we're looking for. We don't know that. So we'll leave that alone. And then a is 5. So 5 squared plus b squared equals 13 squared. 5 times 5 is, of course, 25. B squared, we don't know. And 13 squared is 169. From here, subtract 25 over here, subtract 25 over here. By the way, we're back to what's called deductive reasoning on this. We're reasoning back from a general principle. We're off of our stats unit on inductive reasoning. Okay, so 169 minus 25 is 144. And we're going to take the square root of both sides. All that means is we want the thing that times itself makes the quantity that we have on either side. The thing that times itself makes b squared is b. The thing that times itself equals 144 is 12. We have to put the units. It matters here. I will not give you full credit on problems unless you put units. So b is going to be 12 inches. And you might notice here why the units matter, because in this case we have miles, even though obviously this is not miles, but this is an abstraction of miles on this second problem here. Okay, and so if I wrote down inches for the answer on this one, it would be wrong. Way too small. All right, so the first thing to notice on this one is that, again, the side C, and here I've drawn a situation where maybe it's not so obvious. The side C, you can notice that it's labeled over here, and you also know that it's the hypotenuse because it's opposite the right angle. What am I going to do first? Well, always write down your formula. Okay, so a squared plus b squared equals c squared. In this case, it's c we don't know, so we leave that alone. Both a and b are 5, conveniently. 5 miles, 5 miles. 5 miles squared is 25 square miles plus 25 square miles equals c squared. turn the equation around a little bit over here. Whoops. C squared is going to equal 50 square miles. And to get from square miles to miles, we have to take the square root of both sides again. So the square root of c squared is c. And the square root of 50, well, it's not a perfect square, but it's awfully close to one. You might want to think, what perfect square is 50 close to? Well, 49 is a perfect square. The square root of 49 is 7. And so we're looking for a result that's a little bit over 7. And in fact, the square root of 50 is, I think it's 7.07 something, blah, blah, blah. We'll just say it's about 7.1. So about 7.1 miles. Classic kinds of problems here. I hope that you have fun with them. We're gonna play with a bunch of them for our work in your homework today.